Have you ever tried to learn to code and just gotten completely overwhelmed? Well, today we're going to dig into the philosophy behind a classic textbook that totally shook things up for beginner programmers, and it all started by asking one simple question.
And it's a feeling a lot of us know well, right? You stare at this wall of text, all these strange symbols, and you just think, is it meant to be this hard? It's such a common roadblock. And for way too long, it seemed like the official answer from the world of computer science education was, well, yeah, it is.
And look, this wasn't just in people's heads. In the foreword to the book we're digging into, David Beasley puts it perfectly. He jokes that the most popular teaching languages were, and I quote, masochistic. Ouch. And that right there, that's the central problem we're going to break down.
So, to really get why the solution was so brilliant, we have to first understand the problem. And this whole story kicks off where so many good ones do, with a teacher who just wanted to help his students learn.
So, let me introduce you to Jeff Elkner. The year is 1999, and his high school, like a ton of others at the time, decided to use C++ for their Intro to Programming classes. Now, C++ is a super powerful language for sure, but for kids who had never written a line of code before, it was honestly a total nightmare. Elkner put it best himself. He said he found himself constantly fighting with the language's difficult syntax. He was spending all his energy on these weird, picky rules instead of teaching the actual, ideas behind programming. And that was the light bulb moment. The tool itself was the problem. It was getting in the way of the real learning. He just knew there had to be a better way.
So that frustration launched a quest. Elkner started searching for a better tool. But he wasn't just looking for any other language. Nope, he had a really specific checklist in mind for what would make the perfect language for teaching. And just look at how practical this list is. First off, it had to be accessible, right? Free, available online, and it had to run on pretty much any computer, Linux, Windows, Mac. It also needed to be relevant, something real professional programmers were actually using. But the big one, the most important thing, it had to be easy to learn and, crucially, easy to teach. This was about more than finding a new language. It was about finding a fundamentally better way to teach.
So after looking at all the options, one language just jumped out. It checked all the boxes. That language was Python. But what was it about Python that made it such a game changer for beginners?
Okay, this slide just says it all. This is the aha moment. On the left, you've got the classic first program anyone writes, Hello World, but in C++. Just look at all that stuff. You have to explain what an include means, what void main is, why there are curly braces, all of this just to get a single sentence on the screen. Now, look at the right. That's Python. Print, Hello World. That's it. It's simple, it's readable, it does exactly what it says on the tin. No fluff.
And if you think that code looks different, wait until you see this. To explain that C++ version to a student, the original textbook needed 13 paragraphs. 13! For the Python version, just 2. Just let that sink in. That means there were 11 entire paragraphs of text that were just about wrestling with C++'s complicated rules.
So why is it so much simpler? Well, it's because Python is what we call a high-level language. And all that really means is that it's designed to be a lot closer to how we humans think and speak. It handles all the nitty-gritty, low-level computer details behind the scenes so the programmer, the student, can just focus on the big picture, solving the actual problem.
And this high-level thinking changes everything, even how you explain the most basic ideas. Take something like a variable. In C++, you almost have to think like the computer. A variable is like a specific, named box in the computer's memory that holds something. But in Python, it's way more intuitive. It's just a label, a name you stick on a value. It's a small change in words, but for someone just starting out, it makes a world of difference.
But here's where the story takes a really interesting turn. Because Elkner and the people he worked with realized something huge. The goal wasn't just to find an easier language. The language, Python, was just the tool. It was the key to unlocking something much, much bigger. And this is really the heart of the whole philosophy. The real goal was to teach a method for creative problem solving. Learning to code isn't about memorizing a bunch of weird commands. It's about learning a new way to think. It's a framework for breaking down problems and building solutions, step by step. It's about learning to think like a computer scientist.
So what does that even mean? Problem solving? Well, in this context, it's this really cool three-step dance. First, you have to be able to state the problem clearly. Then, you think creatively about how you might solve it. And finally, you express that solution in a clear, exact way. And that last part, that's where programming comes in. It's just the tool you use to express your solution.
And this mindset is really a blend of 3 different fields. It's got the strict, formal language of mathematics. It has the design and build mentality of an engineer, always weighing different options. And it has the curiosity of a natural scientist, observing things, coming up with theories, and then testing them out. You put all that together, and you've got this incredible mental toolkit you can use for pretty much anything.
All right, so they shifted the focus. It wasn't about the difficult tool anymore, it was about this clear method of thinking. So, what happened?
Well, the impact on students was just immediate. As Elkner said, he saw a higher general level of success and a lower level of frustration. Kids were getting it, they were moving faster, and they were getting better results. But maybe the most important thing was they were leaving the class actually able to build cool stuff and feeling good about programming, not beaten down by it.
And you know, this whole thing didn't just happen in isolation. The book itself was this amazing collaboration. You had a professor, a high school teacher, and a professional programmer all working together. And it was really the spirit of the free, open-source software movement that made it all possible. This idea that we can all build and share better tools together.
Which brings us to the big takeaway here. This story, it's about so much more than just Python versus C++. It's a story about how finding the right tool can completely free you up to focus on what actually matters. It lets you stop fighting the tool and start solving the problem. So that leaves us with a question to think about. What are the problems you could solve if only the tools weren't getting in the way?